Hello students, welcome back to our channel CA Made Easy. So this is the part 3 video of the chapter explaining the mathematics of finance, specifically the effective rate of interest and annuity. You've all been working super hard, and in our previous sessions, we laid down the foundation with simple and compound interest, right? Well, today we're totally leveling up. We're going to take it at a nice, slow, and deliberate pace so you can truly absorb these absolutely critical ICAI concepts. आज हम क्या पढ़ने वाले हैं? What's on the agenda? Well, first, the effective rate of interest. Second, understanding annuities. Third, annuity regular versus annuity due. And finally, future and present values. Let's get right into it. Section 1. Effective rate of interest. Compounding's true power. अब ध्यान से समझना बच्चों. Listen carefully. What actually happens when your bank compounds interest more than once in a single year, like say quarterly or monthly? Well, the actual interest you earn mathematically grows. You see, the nominal rate is just what they advertise on the posters. But the effective rate of interest, that's the true reality. It's officially defined as the equivalent annual rate of interest compounded annually if the interest is compounded more than once in a year. Basically, it reveals the true ultimate return on your hard-earned investment. And here is exactly how you unlock it. Think of this formula like your ultimate anime power-up. Here we go. E equals 1 plus I raised to the power of n minus 1. E is your effective rate. I is your actual interest rate for the conversion period, remember, expressed as a decimal. And n is the total number of conversion periods in that year. Seriously, mastering this formula gives you the true power to see right through any fake nominal rate. Okay, let's look at a real one. ICAI example 22. Suppose you have 5,000 rupees at 6% per annum, but here's the catch. It's compounded quarterly. Step 1. We identify the variables. Your I is 6 divided by 4, which gives us 1.5%, or 0.015 in decimal. And since it's quarterly, your n is 4. Step 2. Apply our power-up formula. E equals 1 plus 0.015 raised to the power of 4 minus 1. Now listen up, because here is a really handy calculator trick for you. On your calculator, type 1.015. Press the multiply sign just once, then press the equals to button exactly 3 times to get that power of 4. Subtract 1 and boom, you get 0.0613. Which literally means your 6% nominal rate magically became a 6.13% effective rate. See the difference? All right, moving on to Section 2, Understanding Annuities, the Power of Consistency. So up until now, we've only talked about single lumps of money just sitting in a bank. But what happens when payments are made regularly? You know, like a monthly pension or paying your house rent every single month without fail. Well, this introduces the concept of an annuity. It's formally defined as a sequence of periodic payments, or receipts, made regularly over a specified period of time. I really want you to let that sink in for a second. Sequence, periodic, regular. Now here's a very interesting point. The ICIA material is super strict about what actually counts as an annuity. There are basically 2 golden rules you have to remember. Rule 1. The amount paid or received must be perfectly constant. It cannot change. Rule 2. The time interval between consecutive payments must be exactly the same. So if a payment series breaks either of these 2 rules, like say you pay 5,000 rupees this year and 6,000 next year, it is simply not an annuity. Got it? Next up is Section 3, Annuity regular versus annuity due. Timing is everything. So we know what an annuity is, right? But did you know there are 2 different types based purely on the exact timing of the payment? Let's break it down. First, we have annuity regular. Here, the first payment takes place at the absolute end of the first period. Second, we have annuity due, which is sometimes also known as annuity immediate. For this one, the first payment takes place right in the beginning of the first period. So it's end versus beginning. ये छोटी सी detail exam में बहुत फर्क डालती है. Seriously, this tiny detail makes a massive difference in your exams. So चलिए देखते हैं, let's look at this visually. While the total amount in each year looks totally identical, 5,000 rupees across the board, year 1, 2, and 3, the actual day the money leaves your pocket or enters your bank totally shifts. For annuity regular, it's like you're paying at the stroke of midnight on December 31st. But for annuity due, You're paying bright and early on January 1st. All right, that brings us to section 4, future and present values, time traveling money. Okay, now we transition to what is easily the most critical segment for your exams. The crucial question we have to ask is, what exactly is tomorrow's value of today's money? Think about it. If you lock away 100 rupees in a physical vault today, it's just going to be 100 rupees tomorrow. Nothing changes. But if you put it to work in the real world with interest, well, the reality totally changes. And guys, this is the very definition of future value. It's the cash value of an investment at some point in the future, compounded at a specific rate of interest. Let me give you a quick example. If you invest 1,000 rupees today at a 7% interest rate, its future value in 1 year's time is exactly 1,070 rupees. Your money has literally traveled forward in time and grown. But hold on. What if we want the future value of a whole series of regular payments, an annuity regular? Well, here is the massive future value formula for it. Now, don't panic, students. I know it looks huge, but logically it is just an extension of the compound interest principles we already know and love. That A outside the bracket, that's simply your periodic payment. The rest of that math inside is just calculating the compounding effect over n periods at I interest. Okay, but what if you're dealing with an annuity due, where those payments happen at the beginning? Our ICII material gives us this wonderfully simple, powerful two-step logic. Think of it kind of like a combo move in a video game. Step 1, calculate the future value exactly as though it's an ordinary, regular annuity using that big formula we just looked at. Step 2, simply multiply that entire result by 1 plus I. Now, why do we do that? Because every single payment has one extra period to sit there and earn interest. Makes perfect sense, right? So, we just travel to the future. But let's keep our momentum going and ask the logical inverse question. What about today's value of tomorrow's money? Well, that brings us to present value. It's essentially backward time travel for your money. We are taking money from the future and we are stripping away the interest to see what it's worth right now, today. Our text perfectly describes it as tomorrow's money discounted at the interest rate. So mathematically speaking, it's just the reciprocal of future value. And just like before, if we have an annuity due, there's a specific step-by-step logic to calculate its present value. Step 1, compute the present value as if it were just a regular annuity, but you do it for n-1 periods. Step 2, simply add that initial upfront cash payment to the value you just got in Step 1. I promise you mastering these logical step-by-step breakdowns is the absolute key to not getting totally confused during your exam. All right, we've covered a lot of ground today, all the way from the effective rate of interest to the inner mechanics of annuities. So, I'll leave you with this one final question. Will you master these formulas, or are you going to let the exam outsmart you? The secret is repetition. Grab your calculators, use those little tricks we discussed, and practice the examples straight out of your ICI module until they literally become muscle memory. Happy studying, Butchone? Keep working hard, and I'll see you in the next one.